Good afternoon, my dear audience, and warmest welcome to the Impact webinar, Step Towards Japan's 12 million hydrogen target. What are the opportunities and future impact? My name is Honem Shah, and I'm a senior content analyst from Media Associates. It's my great honor and privilege to be your host of today's webinar. This webinar is also a virtual session of Asia's top 1 comprehensive hydrogen event, Connecting Green Hydrogen Japan 2024, which will take place from October 16th to 17th at Belsawa Shibuya Garden, Tokyo. In addition to your participation in today's webinar, we also look forward to meeting you in person at this flagship hydrogen events, which brings the highest level of decision makers across the entire hydrogen value chains, including Tokyo Guys, Marubeni Corporation, Mazda, JogMac, Sumitomo Corporation, Uniper, NYK Line, ThyssenKrupp, and much more, to discuss the latest innovations and fill your business future by meaningful connection. In June 2023, Japan released a revised hydrogen basic strategy in efforts to further reduce carbon emission, which set an ambitious target to reduce the annual supply by 6 times from the current level to 12 million tons by 2040. Nevertheless, the follow-up strategic implements securing Japan's industrial competitiveness still need to be identified, and the conversations of overcoming practical challenges for hydrogen to become a fully fledged energy source nationwide should continue as well. Featuring an exclusive lineup of international industry leaders and policymakers from government body, energy utility, developer, and hydrogen buyer, this Impact webinar will comprehensively discuss the impact of the revised plan, Japan-related technology competitiveness, global supply chains, and the feasibility of achieving a hydrogen society in diverse application scenarios, exploring the transformative potential of Japan's vision and its global impact. During this webinar, I encourage all of you guys to actively engage in our discussion. Now, without further ado, I would like to invite our opening keynote speaker on stage, Mr. Eiji Ohita, Strategy Architect for Fuel Cell and Hydrogen at New Energy and Industrial Technology Development Organization. And he will provide us with an overview of how NIDEO is promoting various technology development projects from hydrogen production to unitization in order to contribute to the achievement of Japan's national hydrogen goals. Mr. Eiji Ohita, the floor is open for you right now. Welcome on stage.
Thank you, for your kind introduction. And good afternoon, everybody. I'm Eiji Ohita. I'm in charge of the hydrogen fuel cell program. I'm very happy to be here to introduce the Japan policy and the current R&D activity on the hydrogen. So for the beginning, I have to show about the Japan rough roadmap toward 2050, how we promote the hydrogen. As you know, the area covered by hydrogen is quite wide. So there are many items for the hydrogen supply side, lot of the hydrogen production, lot of the hydrogen transportation. Well, and also demand side, we need transportation, the power generation industry. We need several action for short term, mid term, long term. But I would like to stress for a midterm 2030. It's very important year for us because then we may start then the hydrogen power generation. And to meet then a huge amount of hydrogen demand, we may start to import the hydrogen for 2030. And also to expanding the Japan hydrogen domestic resources, well, we have actually to commercialize the domestic renewable hydrogen also 2030. We just have the 6 years to the very important year 2030. We need to accelerate all of the activities. So, and as Horan mentioned, that Japan just revised it and our strategies in last June. I think that the Japan, the first country, had to develop the national hydrogen strategies in the 2017. And after 6 years, it was revised. There are several points of the revision of the new hydrogen strategy. We have set a new target for 2040 in the hydrogen target, or electrolysis installation target, which is the 15 gigawatt and globally, we may set it to carbon intensity based criteria. But then most of all, I would like to say that the most point of the new strategy is it's not only energy and environment policy, but also the economic policy. And under the new strategies, Japan's government may and pushing to accelerate industry's activity in globally, where new strategy set there are several priority area, which is power generation and fuel cells and electrolysis, hydrogen supply, hydrogen carrier, hydrogen storage technology, or any kind of this priority area, and we may pushing and to develop the new market in the global. So, and the next slide, this slide show the current and the Japan the state about the status of the hydrogen application. And we have the stationary fuel cell, residential fuel cell, which is indirect on the hydrogen uses for the city gas basis. But in a huge number of the unit already installed, you have the 500,000 residential fuel cell in Japan. The mobility sector, we have the 8,000 passenger vehicle, 150 and fuel cell buses mainly running in the Tokyo regularly. You may see the great frequency in Tokyo area, and we have the 170 public stations. And under the private sector, the efforts, and we may develop the several new fuel cell application. And Honda and Toyota announced a new fuel cell vehicle to crown the Honda CRV, and collaborate with the truck company. We may have the heavy duty truck with the Hino or Isuzu. And also the Japan Railway Company GLE is joined in the hydrogen. They started demonstration of the fuel cell train. And recently, the motorcycle company Kawasaki and Suzuki, etc., they developed the hydrogen engines vehicles, hydrogen motorcycles. Well, and for example, the research association of the hydrogen engines, they developed the hydrogen buggy and to participate in the last and Dakar rallies. All right. So from this slide, I will talk about the networks around the activities. And we are working for the hydrogen production, storage, transport, utilization, and we support for the fundamental research and applied research demonstration with the regulation code and the standard. But today, I'd like to pick up our activity about the hydrogen scaling up. Well, and when I work in this, the first slide, I will show about the recent work, but the demonstration of commercial vehicles. We believe that commercial vehicle is a key device to develop the enhanced and hydrogen demand or improve the capacity factor of the hydrogen filling station. Now we're not demonstrate about the heavy duty truck and light duty truck, and through the demonstration over the around the 300 commercial vehicle may join our program. We're also working for our non-load fuel cell application. We are now working for the fuel cell and material handling, which is top handler and lava tire current. It's already developed. It's kind of retrofitted application. We start demonstration, this kind of application at the Port of Los Angeles in this year. We're also working for the fuel cell maritime application and Iwatani and working for the fuel cell ferries, and fuel cell ferry may appear in next year. Well, in the application as a transition, well, we believe the hydrogen gas turbine is a key device to develop and enhance the hydrogen demand. And when I'm working for the small size and the hydrogen gas turbine, which is developed by the Kawasaki heavy industry, we demonstrated over the 5-6 years. And also they're working for a large scale, the 100 megawatt class hydrogen gas turbine power generation. And the Mitsubishi Heavy Industry working for developing the hydrogen converter. Our next step, we may install there's a hydrogen converter for the existing power station. This demonstration may start in the next year. And to meet in the future, the large and hydrogen demand, it's very tough to cover in the domestic and hydrogen in Japan. So Japan the plan to import hydrogen. The challenge is that how to concentrate in hydrogen for long distance transportation. Right. Then and there are several types of the hydrogen carrier we're working on, and but this slide show that our how can liquefied hydrogen activities. And thanks to the Kawasaki Heavy Industry Technologies, we've already developed this small but very first liquefied hydrogen tanker, and our test journey between the Japan and Australia has been concluded successfully. We continue this kind of work, and our next step is to develop the commercial scale hydrogen transportation technologies, liquid hydrogen transportation technology, I'm sorry. And this is the image for liquid hydrogen commercial tanker. And the big point is on the scale. It's the capacity of the hydrogen gonna be in over 100 times bigger compared to the current demonstration level. We may start the construction from this year. Maybe construction may complete in 2027 or 2028. You may see the commercial hydrogen tanker in 5 years. Right. So last year, I will just show about the scaling gap and electrolysis. That's a key device for the high purity gas technologies. And in the short time, we expected the PEM and alkaline is a meeting for the megawatt scale uh, electrolysis. And the left side show our 10 megawatt single stack alkaline electrolysis, and the left and the photo show our 1.5 megawatt and PEM electrolysis. But this is not enough for the commercial side. That we're not working for the scaling up the both of the electrolysis. For instance, and I would show the scaling up on the alkaline electrolysis. We now continue the single stack test at the Fukushima, which is 10 megawatt. And also we are about to develop the multi-module test center in Kawasaki City by the Asahi Kasei Corporation, with conducting the test for 0.8 megawatt and 1.4 unit. It's a multiple unit test. With this is our image for the scaling up with a lining of the 10 megawatt electrolysis stack. We make it kind of multi-module on the system in the future. Well, this is the image for the 100 megawatt, but we may start it for 50 or 60 megawatt and systems, and we may use for the green hydrogen to the chemical production, which such as ammonia. All right, and that's all our presentation, our activity and policy, and our R&D activities. Thank you very much for your attention.
Thank you, Hida-san, for your very informative sharing. I think it's really thought-provoking and insightful. And I do believe United's efforts towards scaling up hydrogen will be finally achieved through various technology development projects, from hydrogen production to unitization that you mentioned in your presentation. So during your presentation, we've already received some interesting questions from our audience, and I'm sure they're thinking to have your answers. So first of all, could you please help us answer something about the domestic production of hydrogen, and what are the major projects Japan is planning to invest at the current stage?
Well, in the domestic production, well, it is not currently we may use the fossil fuel. Well, and now for natural gas and reforming, steam reforming or byproducts. But now we expect the electrolysis is a key device for the enhanced domestic the hydrogen production. Well, combined with expanding the renewable. Now, in Japan, to plan to enhance the renewable, not only the PV, but also the offshore power wind. We now conducted a feasibility study which is suitable places for large-scale power, large-scale hydrogen production. Maybe in the northern part of Japan, western part of Japan, they expected a lot of the excess electricity. And yeah, as I make the presentation, we are working for the scaling up and the electrolysis, and also we are seeking a suitable place for the large-scale renewable hydrogen production. That's the current status of the domestic kind of renewable hydrogen production. Also, the METI, Japan Ministry of Economy and Industry, and now considering to develop the supporting scheme for hydrogen production, which is an kind of the contract for different scheme. It's a reduce the and cost gap between price gap between the hydrogen and fossil fuels. I suppose this kind of the supporting scheme will to help to develop the enhanced domestic renewable hydrogen.
Thank you, Hilasang. And second question is, what actions do we need to see from the hydrogen demand side and also from this policymaker side to realize the really ambitious 12 million ton of hydrogen supply chain?
Yes, and it's a very important point to develop the off-taker, especially large-scale off-takers. And yeah, there are several kind of the off-taker, but in Japan side, we expected, well, in in the power sector, it's kind of the first large-scale off-taker in a possibly. We already collaborate with the Japan's power company to install the hydrogen power generation, also the ammonia for firing the power generation. And the next step, which I mean, the Japan government may try to invite and the industry and who may use the hydrogen, especially located in the coastal area. Because then, as you know, we may import the hydrogen at the port, and many of the power sector power station are located in the port area, and also a lot of the industry like cement and chemical, well, sometimes steel, and also their factory and their plant and located coastal area. We expected that the port at coastal area that's got to be the chance to be a hydrogen hub to develop the enhance the hydrogen demand to meet 1.12 million ton or 20 million ton in future. To accelerate and this kind of activity, also METI also developed the new supporting scheme to provide the subsidy for the infrastructure for kind of the hydrogen cluster, hydrogen.
Thank you, Hilasang, and thanks again for your really detailed answer and participation in today's webinar. And we also look forward to witnessing more supportive policies or subsidies to finally realize Japan's 12 million hydrogen production target. Thanks again for your participation.
Thank you.
Canada is at the table with Japan with a number of international fora working to accelerate the development of hydrogen market, which will support their shared interests and climate commitment, including advancing the sustainable energy transition, ensuring energy security, and achieving net zero emissions. So in the next international keynote session, we are very honored to have Mr. Louis Pierre-Aymon, and he will share with us the hydrogen and its directive opportunities to develop global supply chains in Canada and the current cooperation between these two nations. So Mr. Louis Pierre-Aymon, please start your presentation.
Okay, thank you so much. Let me see if I can share my screen. Okay, yes, thank you. It's an honor to be here today with all of you once again, and I'd like to thank the organizers for the opportunity to share how Canada is contributing towards developing global supply chains for hydrogen and its derivatives and fostering collaboration with Japan on scaling up production. This presentation today, I'll try to be brief, but we'll try to answer three main questions. What can we do together to accelerate the development of global hydrogen markets? How can Canada support Japan's hydrogen objectives? And why is Canada best placed to help?
Sorry to interrupt you, Mr. Aymon.
Yep.
Yeah. I think your slides are not in full display. Can you switch to mode to make it in the full
No,
display?
unfortunately, when I try to do that, I seem to lose all access to the system. So I think if that's okay, maybe I think they're big enough to see.
Yes, it's big enough to say just suggestion, but you can go on.
Yeah, no, thank you. But I tried earlier and it didn't work. So I'll keep going this way. So let me move on then to the first question. So how can we accelerate the development of global hydrogen markets? Canada is at the table with Japan in a number of international fora working to accelerate the development of hydrogen markets. So this work will support our shared energy and climate commitments, including advancing a sustainable energy transition, ensuring energy security, and achieving net zero emissions. For example, I'd like to highlight that in July 2023, during the 14th Clean Energy Ministerial Meeting, Canada and Japan, along with 12 other countries, endorsed a joint declaration to accelerate international hydrogen trade development. Now, this is done by bringing importing and exporting countries together and fostering the dialogue on the nascent international hydrogen trade through the Clean Energy Ministerial Hydrogen Initiative, International Hydrogen Trade Forum. We also work through other multilateral channels, such as the IEA's Hydrogen Technical Cooperation Program and Advanced Fuel Cells TCP. Canada is also committed to continue work with IPHE member countries, including Japan, to provide a deeper understanding of certification mechanisms, as well as a sound basis to support reaching consensus on implementing interoperable certification mechanisms. All these actions are aligned with the IEA's recommendations for governments to provide policy leadership on hydrogen and mobilize investments in hydrogen production, infrastructure, and development. So how can Canada support Japan's hydrogen objectives? Canada and Japan are natural partners. Japan's a key partner in Canada's Indo-Pacific strategy, one of our most important economic and commercial partners, of course, and Canada's largest source of foreign direct investment from Asia. I'd like to highlight how Canada and Japan's long history of close bilateral relations and shared values can help Japan expand its hydrogen market and achieve net zero by 2050. The bilateral relationship is comprehensive and strategic partnership, which is focused on enhancing economic prosperity, addressing climate change and the environment, and supporting energy security. Canada's Indo-Pacific strategy is rooted in this reality and can help Japan achieve its economic and energy security goals. In particular, as the Japanese government is moving to establish a functioning hydrogen society and to promote the use of hydrogen fuel for energy transportation, Canada could be a source of clean energy and materials to support allies like Japan. We're pleased to see strong interest from Japanese industry and in potential ammonia exports from Western Canada, with over $30 billion in projects proposed by companies including Itochu, Mitsubishi, Marubeni, Kansai Electric Power, and other Japanese proponents with Canadian partners. Canada is aware of the producer support schemes launched by the government of Japan to secure imports of 3 MTPA of ammonia by 2030. Since the majority of projects in Western Canada involve long-distance transportation over land by rail, we're working to assess how large volumes of ammonia can be transported safely and reliably. For example, Transport Canada, Natural Resources Canada have established a dedicated team to work on challenges related to transporting large volumes of ammonia by rail to the West Coast for export. All levels of government, namely the federal government of Canada, the provincial government of Alberta, and British Columbia, are working collaboratively together to enhance efforts to address the rail transportation issue. Government of Canada is working towards communicating more on this issue in the spring of 2024. So why Canada? Well, Canada has a long history of developing natural resources with significant contributions from forestry, mining, oil, and gas. Federal policy and fiscal measures have supported academic and industrial research and development, positioning Canada as a leader in hydrogen and fuel cell technologies. As early as 1986, a Canadian-designed hydrogen bus was featured at the 1986 World Expo in Vancouver, and Canadian fuel cells are now found in more than half of the world's hydrogen bus fleet. As you are probably aware, Canada is the fourth largest hydrogen producer, producing some 3 million tons of hydrogen per year from methane for use mainly by the petrochemical and oil and gas sectors. In December 2020, we released the Hydrogen Strategy for Canada, which lays out a framework of actions involving hydrogen as a tool to achieve Canada's goal of net zero emissions by 2050 and position Canada as a global industrial leader of clean renewable fuels. Stakeholders from across government, industry, Indigenous organizations, non-governmental organizations, and academia provided input into the development of the strategy. Canada will be providing an update to its national hydrogen strategy later this year. Canada offers a secure, low-cost, low-carbon intensity natural gas to use as feedstock for production of ammonia. The supply chain in Canada also benefits from suitable and close proximity of underground pore space for carbon sequestration. Exports from Canada's west coast offer significant time savings compared to exports from the US Gulf Coast. Furthermore, Canada's west coast offers a strategic energy security benefits as the trade route bypasses the Panama Canal. The growth of Canadian propane exports to Japan in recent years also serves as a success story that future ammonia exports could potentially build on. Canada has several other strategic advantages for producing hydrogen and ammonia for export, including access to one of the lowest cost natural gas in the world, clean electricity, and leading innovation. In addition, Canada is already a world-leading exporter of hydrogen technology, products, and services, and has a highly educated and skilled workforce. Improving energy security and supporting energy trade with Japan is important to Canada. With advanced infrastructure and production capacity already existing in Western Canada, there are significant opportunities for Japanese investment. Federal policy in Canada includes a suite of measures to accelerate the growth of the hydrogen economy. The Clean Hydrogen Investment Tax Credit can provide between 15 to 40% of the eligible capital costs, with the projects that produce the cleanest hydrogen receiving the highest levels of support, and significantly galvanizing clean hydrogen production across the country. Projects in Canada are currently eligible for this tax credit from the date of its announcement, although formal implementation is still underway. The Clean Hydrogen Investment Tax Credit will also extend a 15% tax credit to equipment needed to convert hydrogen into ammonia in order to transport the hydrogen. The tax credit will only be available to the extent the ammonia production is associated with the production of clean hydrogen. This support will make Canadian hydrogen projects globally competitive. This investment tax credit will not operate alone. Canada also has complementary CCUS and clean technology tax credits, which will also support the hydrogen ecosystem. Beyond tax credits, the government also implemented the Canada Growth Fund, a $15 billion fund that will be administered at arm's length of government, equipped to offer a variety of concessionary supports to keep clean growth projects competitive. The Canada Growth Fund will be able to offer supports, including concessional equity or debt, contracts for difference, and offtake contracts to address green premiums and facilitate market entry. The federal government also has more traditional programming that can support hydrogen projects, including grants and contributions for projects of various sizes. Two notable programs are the $8 billion Strategic Innovation Fund Net Zero Accelerator and the $1.5 billion Clean Fuels Fund. The Canada Infrastructure Bank is already making progress in its priority areas, $10 billion for green infrastructure, which includes hydrogen, of course, and $10 billion for clean power. Together, these measures are intended to create a competitive environment for Canadian hydrogen projects and to level the playing field in light of measures adopted in other jurisdictions. Whatever the size and shape the future hydrogen industry will take, the Government of Canada recognizes that a lot of hard work will be required to make it happen. Large infrastructure projects are complex and expensive. Markets need certainty to develop properly, and hydrogen and its derivatives will succeed only by bringing governments, both domestic and international, industry, and civil society into alignment. Projects may face different challenges depending on what they're doing and where they're located. Projects may need access to grid electricity, permitting for dedicated wind to power electrolyzers, new CCUS infrastructure, or solutions to transport ammonia from inland locations to coastal terminals. Each project presents its own specific opportunities, circumstances, challenges, and needs. This slide gives a snapshot of how Canada's different regions are capitalizing on their comparative advantages to produce and use hydrogen domestically and for export. As an example, in the province of Alberta in Western Canada, the city of Edmonton is building a net zero hydrogen energy complex with a vision that includes over 25 hydrogen production, transportation, and end-use projects, such as houses, trains, and heavy trucking. The Edmonton Hydrogen Hub is acting as a blueprint for other regions across Canada. The growing and emerging network of hydrogen hubs across Canada are critical to the adoption of hydrogen and fuel cell technologies for transportation, power generation, and more. Several multi-billion-dollar projects are being actively pursued in both West and East Coast to support the clean energy needs in Asia and Europe. The Canadian and global hydrogen landscape is a burgeoning sector that continues to have new developments. The recent developments highlight how hydrogen will play a pivotal part in shaping global economies. With that said, consideration must be had for transportation, logistical, and regulatory issues that will need to be addressed. To sum it up, Canada sees a significant opportunity for hydrogen and ammonia, an opportunity that will grow as we work together with our international partners to make it a reality, an opportunity that will take creativity, innovation, and alignment between governments and industry to fully succeed. And that's perhaps the key message to you today. Canada is a reliable, responsible energy supplier. Our work with international allies like Japan to develop a fully emerged hydrogen industry will support shared industry and climate commitments, including advancing a sustainable energy transition, ensuring energy security, and achieving net zero emissions. Canada is a responsible, reliable partner for Japan as we embark together in building the clean hydrogen energy economy of the future. Thank you for your attention.
Thank you, Mr. Iman, and thank you so much for your excellent presentation and detailed explanation of the international collaboration between Canada and Japan, as well as introducing the hydrogen landscape of Canada and its advantages. And here I have some interesting questions from our audience.
Yes.
First of all, can you help us explain why Canada is best placed to help develop hydrogen supply chains for especially Japan?
Well, as I briefly explained in the presentation, I think obviously our location, our resources, where they are located, the government and institutional support that is being provided and being developed, the various programs to help the private sector take a role, both on the Canadian side and on the foreign side. I think we're putting in place the right infrastructure to make it as economically viable as possible for partners, business partners, and foreign partners, countries to look at Canada and think of the reliable partner that we can be for this industry. And the various programs that we are putting in place by our various levels of government and various departments inside of government, I think can provide a very suitable solution for the markets and very specifically here, of course, in Asia, given our geographical situation.
Thank you, Mr. Iman. And we also have questions from our audience, Jane. And our audience want to know, does Canada have any preference for blue or green hydrogen in the comparison of how cost competitive is expected to be production of green versus blue for initial set or projects?
To be honest, we have a preference in Canada to use carbon intensity over color, such as green versus blue, when defining hydrogen attributes. So basically, emissions intensity rather than production pathway will determine the viability of hydrogen and ammonia supplies. So we support all sources and derivatives of low carbon and hydrogen and ammonia that can contribute to achieving net zero in a secure and affordable way, and all pathways that are feasible and that will bring us there. We're open to discuss. But in terms of the coloring of the hydrogen, we prefer to go with the carbon intensity.
Another question, Mr. Raymond. So is Canada looking to be mainly an exporter of hydrogen and ammonia, or will there be some imports that they will looking to buy?
Good question. I mean, difficult to answer without all the proper context, but I would say that generally speaking, given our natural resources and population and size, I think generally speaking, I think it's more likely that some of these products will be exported or consumed locally, and possibly less imported. But again, there's a lot of context that is and information that might affect that full answer. But I think with what I know now, that's probably the best answer I can give.
All right, thank you, Mr. Raymond, and thanks again for your detailed and I think useful answers to our audience. And I think both Japan and Canada are actually active participants in the global efforts to promote hydrogen as a clean energy source. And I also believe their collaboration holds, promise for leveraging each other's strengths in this field. And thanks again for joining us today.
Thank you.
Like Canada, Belgium and Japan have also taken important steps towards development of hydrogen economy. Both countries have published comprehensive hydrogen strategies, launching a project and investing in new infrastructure. So in our next Belgium chapter, Mr. Joran Kaper, the head of economic and trade session from the Embassy of Belgium in Tokyo, will talk about the key consideration for the cooperations between Belgium and Japan to consolidate international hydrogen supply chain. So Mr. Kaper, welcome on stage. Sorry, Mr. Capers. We can't hear you right now. It seems like you are not connected to the audios. Could you please check your audio?
Can you hear me?
Yeah, I can hear you good.
Okay, can you see my screen?
Yes, I can see your screen as well.
Okay, sorry for that. I had some technical issues. Yeah, so pleasure to be with you today. I will be speaking about hydrogen cooperation between Belgium and Japan. Before I do that, I would like to briefly give you an outline of what Belgium is doing in terms of hydrogen. The Belgian federal government published its hydrogen strategy in 2021, which has since been revised to reflect higher ambitions. The main goal, the main purpose of our strategy is to position Belgium as a hydrogen hub in Europe, as a hydrogen import hub in Europe. Now, we do expect that there will be hydrogen production in Belgium, some hydrogen production in Belgium, but we will not have enough renewable energy capacity to produce hydrogen at scale. And so we are looking at becoming an import hub for hydrogen into Europe. We expect the Port of Antwerp to be a crucial entry point. The Port of Antwerp already has a large concentration of hydrogen-consuming industry, and also already has an existing hydrogen pipeline network that can be used for this goal. When we look at the import for hydrogen into Belgium, we see mainly three routes. So the North Sea route, we expect there will be a lot of hydrogen production in the North Sea based on offshore wind that can be shipped to Belgium through pipeline. We expect also the southern route to be a viable route for hydrogen imports. So the southern route meaning from Spain, Portugal, and perhaps North Africa through pipelines to the rest of Europe. And then provided that costs come down, we also, of course, think that hydrogen could become shipped. And so we also think that in the medium term, we will see shipping routes develop for hydrogen to Belgium and other ports. Now for this import hub, we are actively looking for supply deals with third countries. So we have signed agreements with countries like Oman and Chile. We also have Belgian companies that are active in hydrogen projects in countries like Morocco and Namibia. So we are trying to diversify as much as we can our hydrogen supply network. The hydrogen that we intend to import into Belgium will not only be for Belgium. We also want to become a transit hub for Western Europe and to have hydrogen transit through Belgium to other European countries in the neighborhood. Germany, France, Netherlands primarily. We already have a lot of hydrogen pipeline infrastructure today, and the Belgian government and private sector are investing heavily into expanding pipeline connections with neighboring countries. We also want to be a knowledge hub and build up our own expertise when it comes to hydrogen. And so the Belgian federal government has funded the creation of a hydrogen test center, which will allow Belgian companies and foreign companies to work together and test certain industrial applications for hydrogen. We're also supporting industry federations and are participating in European and international hydrogen initiatives. So that's sort of the general idea of how Belgium wants to position itself when it comes to hydrogen. Where do we see potential for hydrogen in industry or in the economy in general? Our strategy identifies 4 key sectors: industry, transport, power, and buildings. Especially industry and transport are 2 sectors where we see a lot of potential for hydrogen. As I said, we already have a large chemical industry in Belgium that is using hydrogen. And of course, we think that it could also be an interesting way to use hydrogen as a fuel to decarbonize industrial heating processes. We also see hydrogen play a role in heavy-duty transport and as a fuel in shipping. There could potentially also be a use for hydrogen in the power sector and in the building sector. But for the moment, Belgium is very much focused on industry and transport. Now, how could we work together with Japan? I think Belgium and Japan are in somewhat of a similar position in the sense that we will probably be more importers of hydrogen than exporting hydrogen. So I think cooperation could focus on 3 areas: industrial partnerships to further develop hydrogen technology, R&D collaboration into the potential of hydrogen applications, and lastly, of course, regulatory cooperation. And for that last part, I think the EU-Japan MOU on hydrogen that was concluded in December 2022 will be very important. It has different goals, but including working on common standards and certification and exchanges on best practices and lessons learned, and also working together on different projects. Indeed, if we want hydrogen to become a global commodity, we need to work with partners like Japan and others to develop the necessary standards and certification. Now, when it comes to those first 2 pathways for cooperation with Japan, so industrial partnerships and R&D, we already see a lot of cooperation today. And I would just like to cite or give 4 examples of ongoing projects that I think could be a template for future collaboration. The first project is a collaboration between Bekaert and Toshiba. So Bekaert is a Belgian industrial company, and it reached an agreement earlier this year with Toshiba, a major Japanese industrial player. And both companies will work on PEM electrolyzers, so they will combine their technology that will help to produce green hydrogen at scale. So that's one example of an interesting industrial partnership. Another one in the shipping industry this time, Compagnie Maritime Belge, CMB, and Tsuneshi. Tsuneshi is a Japanese shipbuilding company. So CMB and Tsuneshi launched a hydrogen-powered ferry in Japan in 2020. So this is a small passenger ship that uses hydrogen as a fuel. It's currently active here in Japan, and following the success of this ferry, both companies decided to launch a joint venture in 2021 to further develop hydrogen applications and hydrogen engines for the shipping industry. And one of the projects that they would like to do is to build a hydrogen-powered tugboat, the Hydro Phoenix, which would be a first for the Asian market. There was already a similar hydrogen-powered tugboat active in Belgium, but this would be the first one for the Japanese and for the Asian market. Another example from Belgium itself this time is H2PY Serein. So this is a pilot project that is financed by the Belgian government, looking into the use of plasmalysis technology for hydrogen production. And so the winning consortium consists of a number of different companies from Belgium and Europe, but it also has the involvement of AGC Glass Europe. So AGC is a major Japanese industrial company as well, which has its European base in Belgium. And so they joined this consortium to work on exploring plasmalysis technology. And then a final example of the kinds of cooperation that I think we could see in the future. Of course, on R&D, the High and Heat project is an EU-funded project which looks into the use of hydrogen as a fuel for high-temperature industrial heating processes. So specifically looking at hydrogen in the aluminum and steel industry. It's a consortium of different European companies. Some are Belgian, some are German, others come from Spain. And the consortium also includes Toyota Motors, which has its European headquarters in Belgium. So Toyota Belgium will participate in this project as well. So that's just to give a short overview of what we're seeing today, and I think we will see more of these projects in the future as the hydrogen economy really starts to take off. As I said, we are very interested in cooperation with third countries, including Japan. We already have some collaboration going on, and I think we will see more of the same in the future. I will end my presentation here, so thank you very much for your attention, and happy to answer any questions if you have them.
Thank you, Mr. Tevers, for your very kind sharing and great potential of the Belgium-Japan cooperation between different sectors. So during your presentation, we have some questions for you. I want to hear your answers. So first of all, what are some of the challenges Belgium is seeing in developing a hydrogen economy?
Yes, thank you. Well, we're seeing, I think we're seeing different challenges at the moment, but when it comes to hydrogen specifically, we've taken a lot of steps to really support companies in developing hydrogen technology, but we're still seeing that the demand side is not following yet. A bit similar to what was said earlier in the NATO presentation, I think we need off-takers, we need the demand side to grow. And so that's one area where I think we still need to try and support companies to build up demand for hydrogen if we want hydrogen to take off as a viable energy carrier. It's also cost of energy, of course, is at the moment quite a challenge. We need to lower the cost of hydrogen production as much as we can to make it viable. Energy prices in Europe are still quite elevated at the moment, so that's also another challenge. And thirdly, I think we will be an importing, as I said, Belgium will be an importing country, most likely. So this is more of a risk, I would say, but we need to make sure that we diversify as much as possible our suppliers base. We don't want to repeat the mistakes of the past where Europe was dependent on a limited amount of energy suppliers. So hydrogen offers the possibility to diversify our suppliers when it's in terms of hydrogen.
Thank you, Mr. Cavers. And the second question is, what are some of the similarities and differences between the Japanese and Belgian hydrogen strategies that you mentioned in your presentation?
Thank you. Yes, I think there are quite some similarities. In general, as I said, I think both Japan and Belgium will be more importing countries than large producers of hydrogen. So that will be similar. I don't think we will see any kind of direct supply link between Belgium and Japan, of course, but we will be looking at different suppliers. Some of those suppliers might be the same countries. When we look at applications, I think quite some similarity as well. Japan is also looking into hydrogen for industry, for instance. This is definitely also a major focus for us. There are some differences I see, for instance, when it comes to transport, I think, and this is not just for Belgium, but for Europe in general, there's less emphasis placed on things like fuel cell cars or hydrogen fueled cars. So we do think that hydrogen can play a role in transport, but specifically for passenger cars, for instance, we are more looking at EVs. Whereas I think Japan has put more emphasis on developing hydrogen cars. But overall, I think it's quite similar strategies, similar direction, and of course we have a lot to learn by working with each other.
Thanks again, Mr. Cavers, and really appreciate your generous answers. And I do believe that ongoing collaboration will greatly leverage both Japan and Belgium's technological experts and the market demand, accelerating the development and adoption of hydrogen as a clean energy solution. Thanks again.
Thank you very much.
And now, without further ado, let me introduce our next keynote speaker, Mr. Ashwani Dudaija, the President and the Director for Green Hydrogen and Ammonia at ACME Group. Ashwani will give us a keynote speech on exploring the potential of supplying Japan with green ammonia from India. So welcome on stage, Mr. Ashwani.
Hey, just a quick check. Am I audible, visible, and is my slide visible?
Yes, both your camera and your slides are visible right now.
Excellent. Okay, so good afternoon, everyone, and thank you for inviting us to this webinar. And it's a very important thing, given the India and Japan relationship. The topic is very appropriate. How can Japan benefit from the very close relationship with India, where there is a lot happening in terms of creating a green molecules hub with very, very active support from the current government. And this is the first time even for India, being a net energy importer, to look at the possibility of exports. But before I talk about this, let me just start with a small brief introduction about our company. So we are about a 2-decade-old organization, one of the top renewable players in India, with a current portfolio of about 8.5 gigawatt renewable power. All of this is in form of independent power, which we sell to various state-owned entities. And back in 2020, we started venturing into green ammonia space, and we developed what perhaps was the world's first fully integrated green ammonia project. It's a small pilot, 5 tons per day facility west of Delhi, about 400 kilometers west of Delhi, in a place called Bikaner. So I'm going to show you a very small video of this facility, just as an introduction to what we are doing. And please let me know if this is audible and visible. Probably the audio may not work. Okay, look, I think audio. Can you hear the audio?
Sorry, Mr. Ashwani, we can't hear the audio, but I think you can
Okay.
choose the share audio button while you're sharing your screen. You can
Okay,
find
no,
the
that's fine.
function.
Basically, this is the plant which we built in 2020, and it's a 5 tons per day facility, as I mentioned, and everything which could have failed in this plant has already failed. Some of the equipment failed more than once, but we are very proud to say that this facility is now working for 24 months, more than 24 months in continuous operation without any breakdown. And we are loading 1 truck of green ammonia from this facility every 12 to 15 days. And this has given us a lot of confidence and experience in operating the alkaline electrolyzers, which are installed here. More than 60 operators have been trained, more than 50 delegations, of which there were more than 30 international ones, have visited this facility. And this is our starting point back in 2020, when not many people were talking about ammonia. There was only discussions on hydrogen being one of the possible green fuels helping in the energy transition, but not so much attention was being paid to ammonia. And because we ventured into this quite early, we also were looking at what are the various places globally where we can develop the cheapest plant where we can produce the cheapest molecules. And Oman turned out to be one of the favorite destinations in terms of the solar intensity, the wind potential, the locational aspects, the political stability, and various other factors on which we were evaluating. So very happy to share that we are now developing our first large-scale facility of 100,000 tons in Oman. But that's not the only project. In the last several years, we have developed a pipeline of our projects, supply projects in various places. Duqm in Oman is going to be the first one and likely to be commissioned sometimes in 2026 second half. Following that very closely will be East Coast India project in Gopalpur, from where we are going to produce about 400,000 tons of ammonia in the first phase. And all of this ammonia is going to be targeted towards the Japanese market. We already have a term sheet which we have signed with the IHI Corporation of Japan. And following this would potentially be a project in Port of Victoria, Houston, Texas, and another one on the East Coast India, which is down south in Tuticorin. Each of these projects is typically going to be about 1.2 million tons and to be developed in phases as we capture more and more demand. And to capture such demand, we have set up a global presence with the officers or representatives. And as we speak right now, I have my colleague Kono-san, who is also attending this session. So any of you in Japan, if you need any more information, Kono-san would be very happy to talk about it offline. And we have a series of firsts. Of course, our Bikaner plant, as I mentioned, is perhaps the first global plant on an integrated basis. We were the first one to have obtained a TUV certificate for our Oman project, being green hydrogen and green ammonia compliant. We signed the picture on the left top, which you are seeing is the term sheet which we signed with IHI Corporation in India. The one below that is the agreement which we signed just 2 weeks ago with Yara. And this is the binding agreement without any conditions for the supply of 100,000 tons of ammonia from phase 1 of Oman. We have already done the financial closure for our Oman project, and I will just show you quickly a couple of pictures from our site in Oman, where the basic construction activities have already started. So that's a very short summary about ACME. I just would very briefly cover some of the challenges which already have been mentioned by some of the speakers previously. I think one of the challenge which everyone talks about is the demand side. But I want to just go beyond demand. Of course, finding demand is the most difficult thing, but once you have found the demand, structuring a commercial contract is even more difficult, I can tell you. It's not so straightforward. There are no templates available, unlike LNG industry. There are no standard pricing structures which are available. So you have to do all the discovery between the buyer and seller, and that makes it extremely challenging for both the parties to find common ground. We also have heard in the previous session about the regulations part, and that to me is a very important aspect. Europe has very clearly taken a stand of going towards renewable fuel of non-biological origin and has established some guidelines and directives under Renewable Energy Directive 2 and 3 is also in the process. But a similar thing has not really been done in Japan or many other parts of the world, which actually creates another very big challenge for a project developer like us. And the only other one which I would like to talk about in this slide is the end-use applications, which is very important. Most of the project developers at the moment are targeting the low-hanging fruits, which is the existing fertilizer and chemical companies. But there is a case for looking at newer applications, and Japan actually has taken a big lead. We saw how hydrogen running ferries have already been deployed back in 2020 in Japan, but there are direct ammonia firing applications which also have gained a lot of prominence in Japan. There are turbines which can run entirely on ammonia in mono-firing mode. There are turbines which very soon will be developed or retrofitted existing gas turbines which can burn ammonia directly, so avoiding the need for any backcracking and losing more energies or making it even more or less competitive compared to the fossil fuels than it already is. And last slide is really in terms of how India and Japan can work together in making some of the projects in India, but also the supply opportunities in Japan, a possibility, a reality. And I would like to start by saying that Japan has done a fantastic job in creating a whole industry in LNG. 25 years ago, 30 years ago, Japan was the only country who were talking about or signing long-term LNG contracts, anchoring a lot of these large-scale projects which came up in Middle East and various other parts of the world. And something similar should be used for developing the market for ammonia and hydrogen in Japan. on the regulatory front, as I already said, Europe has taken a very clear path towards electrolysis-based hydrogen and ammonia, but Japan has not done so far, has not announced any kind of regulatory aspects or certification aspects which will clearly distinguish the blue projects or the blue ammonia from the green ammonia. And our one of very strong recommendation as a company which is focusing only on green rather than blue or gray projects is to focus on green projects, because we all talk about reducing the cost of green ammonia and hydrogen in the longer run as the economies of scale increase, but the economies of scale is not going to happen until there is a demand and the projects are developed for green hydrogen. Otherwise, we keep on talking about blue being transition and green being the end, and there's no end to this transition. So our very strong recommendation is, of course, price is a very important criteria, but one very good aspect, which some of you in this call may already be aware, is the shorter shipping distance between India, East Coast, and Japan versus from US via Panama Canal, which anyways is a bit risky, to Japan. And that difference is nearly $100 in shipping cost. And that anyways creates a very big incentive for the buyers in Japan to look at green projects in Indian East Coast compared to the blue projects in US. And also, talking a little bit about certification, as I said, there are in Europe already RED II, Renewable Energy Directive 2 mandates, and something similar we recommend should also be implemented in Japan. The various other areas, which again, some of my past speakers have already highlighted and not spent too much time on that, but one of the important ones for India would really be funding. And what one of the ideas we have been discussing, and I know my next speaker is our friend from JBIC, and we have discussed this idea with them also, is to extend longer tenure loans, which are denominated in yen. And that's only possible if you also have an offtake for such projects in Japan. So some of those innovative structures on funding can also help reduce the cost of delivered ammonia into Japan. And just as an example, every 100 basis points differential in the interest cost can be, of course, it will vary from one project to another, but just on an indicative basis would be equal to $30 per ton of ammonia price difference. And that's a very significant amount, and Japan government and agencies in Japan should definitely consider this as one of the options. And last but not the least, again, already said by my previous speakers, is to use the technological advantage which Japan has towards developing very high efficiency products, specifically electrolyzers, the membranes, and various other elements of the entire ammonia production value chain, can be passed on in form of either joint venture or the manufacturing arrangements at a cheaper location like India, where the cost of manufacturing would be much lesser, but then it also helps in developing an altogether new industry, which is eventually going to both benefit both India as well as Japan. So with that, I will stop and invite any questions if there are.
Thank you, Mr. Ashwani, for your really impressive sharing of ACME Group's international ammonia project and the potential challenges or main consideration for this project, for developing green ammonia project, as well as the useful recommendation for Japan to become a global leader in green ammonia. And yes, it seems like our audience are really actively engaged in your session and are really interested in your content. And I have to select two questions from different perspectives. One is from a business market perspective, another is from technological perspective for you to answer. So first of all, as you mentioned, the featured Oman project. So our audience was actually wondering what was the key reason for selecting Oman for the first large project rather than the other, hot market like India, Saudi Arabia, or Egypt.
So if I give you the real answer, people are going to not believe me. But the thing is that all of this was happening during COVID, and there were no commercial flights between many countries, and we were reaching out to various countries. We, of course, did our selection of top 5, 7 places where we would like to develop a project and where we can deliver the lowest cost of hydrogen ammonia. Oman, of course, was ranking in the top 3. But I must acknowledge or confess that Oman was the only government which responded at that point of time, and we were corresponding with them, meeting with them using the chartered flights. They were very, very proactive. They were very welcoming compared to any other destinations where we reached out. So it is a little bit of design, but also a little bit of default, by which we ended up being in Oman. And
Thank
of
you.
course, India, we are developing another project. The reason we did not start in India was because back in 2020, there was no incentive in the Indian green hydrogen ammonia space. It's only last year that the Indian government created a national green hydrogen mission, under which there are a lot of incentives which have now been created. And as soon as this was done, and with very active contribution from our side to the government, we immediately created 2 opportunities. And as I mentioned, one of those is going to be feeding into the Japanese markets, which is our project in Odisha. So we are not ignoring India at all. It just happened that the sequencing wise, Oman happened much before Indian government came up with the incentive schemes in India.
Thank you, Mr. Shwani, for your explanations. So over the 24 months of continuous operation, have you observed a degradation rate from the electrolyzers? And is there any drop-off in production capacity due to aging or increase in power consumption?
So that's a very interesting question, and this is the second time in last 2 days this question has been asked. But unfortunately, I'm not a very technical person. I did my engineering 30 years ago, so I'll have to really go back and check. One thing I can tell you is that, of course, these electrolyzers are not running on a 24/7 basis. They run only when the sun shines. So roughly you can say about 7 to 8 hours, or sometimes even we are lucky 9 hours in a day. And the most difficult part really is the startup and shutdown, which we have learned over the last 3 years that we have been running this plant, and are very pleased and confident that we can run these alkaline electrolyzers. Whether there is any degradation, I am not very sure. There perhaps is some degradation, but I'm not aware of how much quantum of degradation has happened. And one thing I do know is that the most important part of electrolyzer is the membrane, which is working perfectly fine. Of course, we had some failures, as I mentioned, in the initial part of our startup, and we had to do a lot of replacement. But since last 24 months, these are running continuously with no problems with the membranes, and hopefully the lifespan which is committed by the vendors of about 10 years is something which we are likely to get.
Thank you again, Mr. Ashwani. And we look forward to learning more of your insights in our in-person event, Connecting Green Hydrogen Japan in Tokyo this October. Thanks again for joining us today.
Thank you.
As we all know, Japan plans to spend 3 trillion yen over the next 15 years to subsidize the production of cleaner hydrogen, aiming to boost cooperation with the private sector to develop a domestic supply chain for energy source. And therefore, in the next keynote session, Toyota Kohi-san, a Director General for Energy Transformation and Strategic Energy and Natural Resources at the Japan Bank for International Cooperation, JBIC, will provide us with insights into Japan's public-private partnership of financing the hydrogen value chain. So Toyota Kohi-san, please start your presentation.
Can you see the slide?
Yeah, we can see it well, but I think it's in presenter mode. If you can adjust the display mode, that would be better.
Working.
I think it's still in presenter mode. Can you try to make a full display?
How about this?
It's better right now, but I think we can just skip this part and you can continue your presentation. No worries.
Okay. Okay. Hi, everyone. I'm Kohei Toyoda, Director General for Energy Transformation Strategy, Japan Bank for International Cooperation, JBIC. First of all, thank you for having me today. I'm going to talk about the financing the H2 value chain, Japan's public-private partnership. As Ohira-san already explained Japan's hydrogen strategy as the first session, so I will go into the detail of this slide. But one additional information is the GX you can see in the red square at the top right-hand side is one of the most important policy agenda for Kishida administration. GX is a green transformation. The Diet approved the GX Promotion Act in May last year. And I think this is the Japan's version of IRA, Inflation Reduction Act, in the US. And Japan will invest $1 trillion for green transformation in 10 years. I will explain the detail later. So I will skip the government target of hydrogen, volume usage and hydrogen cost target. But Japan will utilize hydrogen for industry, mobility, as well as power generation. And also Japan will utilize SAF, e-methane, e-fuels, as you see the bottom of the slide. As we all know that the biggest challenge for hydrogen is the cost. This slide shows the cost parity of hydrogen. The data is a bit old, but still valid for this discussion. Mobilities such as light-duty vehicle is the most promising option from cost parity point of view, as you can see the graph left end. But hydrogen consumption volume of FCV is quite small compared to the power generation steelmaking process. For example, annual hydrogen consumption of 500 megawatt hydrogen turbine is around 200,000 tons, which is equal to 2 million FCV's annual hydrogen consumption. And as Ohira-san explained, the cumulative sales of the FCV in Japan is around 8,000. instead of 2 million. That means in order to utilize hydrogen in a large volume, we need to utilize hydrogen in power sector or industry sector, especially steel making or cement chemical. But as you can see in the middle of this graph, in order to utilize hydrogen in these sectors, we need to reduce cost of hydrogen substantially. That means substantial cost reduction and also the increase of GHG emissions through carbon pricing are the key driver to expand hydrogen demand in Japan. And there are 3 ways to reduce cost of hydrogen: technology innovation, economy of scale, and reducing cost of capital. For technology innovation, Ohira-san already covered the issue. But the government established 2 trillion yen Green Innovation Fund, which is around 30 billion US dollar, in supporting various hydrogen-related technology development. And for economy of scale, GX Promotion Act is a key enabler. And this slide shows outline of GX Promotion Act. If you see upper left-hand side, Japan will make all the effort to achieve carbon neutrality, including the introduction of hydrogen ammonia. And if you see the lower left-hand side, Japan will invest 150 trillion yen, about 1 trillion US dollar, in 10 years for green transformation by both public and private. And in order to induce such large amount of investment, government will issue 20 trillion yen GX transformation bond, which is around 130 billion US dollar, to support early movers. The government also introduced carbon pricing framework, such as Japan ETS, carbon credit auction, carbon duties, to redeem the bond, as well as increase the cost of GHG emission. Right-hand side is a breakdown of this 150 trillion yen. Japan will invest minimum 7 trillion yen for hydrogen ammonia supply chain development, as you can see in the top. And in order to increase the demand of hydrogen, which is a quite expensive energy for many off-takers or end users, the government of Japan will introduce large-scale support program, which is similar to Contract for Difference in the UK. The Japanese government bridged the gap between strike price, which enable hydrogen suppliers to recover the cost and receive reasonable return on their investment, and the reference price, heat equivalent price of existing fuel such as coal and gas, which enable off-takers or final consumers to utilize clean energy such as hydrogen at no or little additional cost for 15 years. And the government will spend 20 billion US dollar for this program. On capital cost, I'd like to introduce the World Bank's flagship hydrogen report, which was published 3 weeks ago, and JBIC was a part of the working group. Hydrogen production requires large amount of investment, especially green hydrogen. This is a ballpark figure, but in order to produce 1 million tons of green hydrogen 1 year, we need 10 gigawatt electrolyzer, 20 gigawatt renewables, and 30 billion in investment. And cost of capital substantially affects the cost of hydrogen. For example, if you see the graph at the top, if we can reduce capital cost from 50% to 5%, hydrogen price will fall by 45%. And in order to reduce the cost of capital, we need to maximize utilization of the debt or loan instead of equity, because the cost of debt is much lower than equity, as you can see bottom of the slide. On the other hand, debt providers, including banks, are risk averse because their profit margin is slim and there's no upside profit. That's the reason why de-risking or creating the appropriate risk allocation framework is very important to reduce the cost of capital and reduce cost of hydrogen. This is the image how we can reduce the cost of capital by de-risking the project. For example, we can reduce the volume risk by long-term offtake. We can reduce credit risk by partial loan guarantee. We can reduce price risk through contract for difference support. We can reduce offtake risk by developing spot market. We can reduce political risk by insurance, or we can reduce infrastructure risk by hydrogen hub development. As a policy-based financial organization, JBIC is contributing to by not only providing competitive long-term financing, but also by creating de-risking mechanism or appropriate risk-sharing mechanism in collaboration with government, investors, developers, off-takers, technology providers, contractors, and financial institutions. And next, I'd like to introduce JBIC's organizational capability and our effort to support hydrogen business around the world. JBIC is a government financial organization 100% owned by the government of Japan, and we are supporting Japanese businesses, including Japanese companies' investment, export, as well as the import of natural resources, and nowadays including hydrogen. And JBIC has implemented 3 initiatives to accelerate or to enhance our effort to support hydrogen projects. In July 2022, we established Energy Transformation Strategy Office. The office is responsible for all the debt-related hydrogen transactions around the world, from upstream to downstream. I'm the head of the office. Second, JBIC introduced Global Investment Enhancement Facility, which was approved by the government of Japan. We have 2 virtual windows under this facility. And by utilizing sustainability window, you can see lower left-hand side, we can provide competitive financing to support hydrogen-related projects. Thirdly, JBIC expanded its risk-taking capability through so-called special operation, which utilize funds from independent special account. And using this special operation, we can take technology risk or project formation risk. And in fact, we already made equity investment into hydrogen station project in California, as you can see the small picture in the bottom. In addition to these initiatives, JBIC is expanding our hydrogen network by signing MOUs with major hydrogen players around the world, including private companies, government, or government-related entities. Finally, this slide summarizes how JBIC supports creating the global value chain around the world. Basically, JBIC supports everything from upstream to downstream, both green, blue, maybe turquoise, purple, and we will support all the hydrogen carriers, including liquefied hydrogen, ammonia, MCH, PNG, synthetic fuel. Also downstream project. This comprehensive approach is similar to what we did in the past when we developed energy value chain from scratch. But this time, JBIC will be more flexible, more speed, much more speedy than in the past. So because of time constraint, I'm stopped here. Thank you for listening.
Toyota Kohisan, many thanks for your kind sharing of Japan private partnership of Japan's hydrogen value chain. And I'm sure this is a very solid presentation for our audience who are eager to explore the hydrogen investment opportunities in Japan. And during your presentation, we've already received some questions from our audience who are seeking to have your answers. So first of all, could you please help us explain what are Japan's strengths and weaknesses in leading the global hydrogen society in terms of hydrogen investment and technologies?
Thank you. Japan has many advantages, including a technology advancement. And also, Japan is developing several hydrogen carriers. In some countries, they don't need this kind of hydrogen carrier. It's a local production, local consumption. In case of Japan, Japan will import hydrogen. So hydrogen carrier is very important, and Japan is the leading player in developing hydrogen carrier technology. At the same time, big disadvantage is the production cost. Our renewable energy is very expensive, and we have no gas or fossil fuels. That's the reason why we need import hydrogen from supplier countries, maybe like India, Australia, Middle East, US. So the cost is big disadvantage, but we can cover this disadvantage by our technological, let's say, advantage, together with government strong support and JBIC support, I believe.
Thank you to Toyota-san. Another question from our audience, and our audience want to learn, like, is there any Japanese government plan that owned financial institutes such as JBIC, and which have some program to support such domestic hydrogen production project?
Yes. Unfortunately, JBIC cannot support the domestic hydrogen production project in Japan. It's beyond our mandate. But the big government support program I explained is eligible for local production hydrogen project. And this is a big enabler for the domestic hydrogen players to move forward.
Thank you, Mr. Kohi-san, and thanks again for your informative answers. And I also look forward to meeting you in person at our physical events in Tokyo this October. Thanks again for your participation to this webinar.
Thank you.
Decarbonization in Japan will require more than 150 trillion in public and private GX investments over the next 10 years in a wide range of sectors, including energy, manufacturing, transportation, and life vehicles. So the private financial sector is also supporting the promotion of GX investments in the private sector through expansion of sustainable finance initiatives and efforts to promote the social implementations of new energy. Following our last keynote speech, Tadahiro Kaneko-san, the senior aide to unit head of global banking at SMBC and chair of finance committee of Japan Hydrogen Associations, will discuss how to catalyze GX related investments from private sector. And now let's welcome Tadahiro Kaneko-san.
Hi, thank you very much for the introduction. My name is Tadahiro Kaneko from SMBC and also chairing the finance committee of JH2A, Japan Hydrogen Association. And I was pretty much interested in Mr. Toyoda's presentation around cost of capital of debt and equity for the hydrogen projects. And I would like to briefly introduce how private commercial banks like SMBC Group is getting ready to hydrogen. And also associations such as Japan Hydrogen Association, who are joined by more than 400 private companies as well as municipalities, progressing toward social implementation of hydrogen. Next page, please. Firstly, I would like to introduce the SMBC Group's revision of materiality that was implemented April last year. Our group actually revised the corporate materiality after more than 10 years and break it down to the 10 different goals. And as you can see on the upper side of this page, we place environment as a first important pillar, and putting the support for the transition to achieve decarbonization of the society as a top priority. As you can see on the right, such a goal is attached with the sustainable financing origination target as much as 50 trillion Japanese yen in the coming 10 years. This was actually upwardly revised in the past 5 years for twice, originally from 20 trillion yen to 50 trillion yen, and gradually including various type of sustainable financing, including climate transition financing, as well as social financing. And also, if you see this materiality, at the bottom, we have Japan's regrowth. So potentially in the future, financing hydrogen projects with some Japanese interest attached will really contribute to this aspect as well, because we are trying to support Japanese business growth in that regard. Next page, please. Right. You can see on this page, I would like to introduce SMBC's Transition Finance Playbook, which was published May last year publicly, which is actually formulated in the intention that we really would like to support the financiers like banks, as well as borrowers or the bond issuers for the actual financing through the transition finance. And we separate the use of proceeds into two parts, the general corporate purpose, as well as the use of proceeds for the specific projects. And basically, set up a guidance for the regional based on the regional characteristics, as well as the regional policy differences, and whether we label any specific financing as a transition financing or the transition support financing. Next page, please. Also, SMBC Group has been demonstrating a strong commitment to hydrogen relatively early among private financial groups in the world. For example, we SMBC Group joined the International Association of the Hydrogen called the Hydrogen Council in the year 2018, only a year after the initiation of the association. And since then, internally, we have been having a designated hydrogen team within the company, and gradually proceeding to promote the social implementation of hydrogen. Also, after many governments' declaration of the carbon neutral policies, this hydrogen became a really important key item, particularly for the hard-to-abate sectors. So SMBC is really committed to promote hydrogen in order to proceed the commitment along the achieving net zero emission. Next page, please. Here, I would like to briefly introduce the Japan Hydrogen Association, JH2A, which was actually initiated at December of 2020, more than 3 years ago, with three co-chair person from Toyota Motors and Iwatani Gas Company, as well as an SMFG ourselves. And it actually started with a little more than 90 companies as a membership. But at the moment, we already have more than 400 membership from private companies as well as the municipalities. This association actually have 5 different committees, as you can see on the right hand of this page, one page before, sorry. Sorry. Yeah, can we move back to the previous page? One page before. Yes. Yeah, I was talking about the JH2A's committee, as you can see on the right-hand page. And of course, obviously, we do have a finance committee, and we have been discussing about setting up a hydrogen designated equity fund in order to really promote the social implementation. And we are really in the process of this formation of the hydrogen fund at the moment. Last year, we decided to retain advantage partners as a GP partner, in addition to Sumitomo Mitsui DS Asset Management as a former original GP partner, as well as a financial advisor of Mitsubishi UFJ Morgan Stanley security company. And we also have a commercialization committee who is really engaging into the commercialization of the different parts of the broad hydrogen value chain. And also our regulation committee is really working on challenges for the different parts of the regulations associated to hydrogen. And also, when we speak about this type of new energy contributing to decarbonization, the carbon intensity standard as well as the product standard is going to be key for the discussion. And the CO2 free hydrogen committee is really working on this side. Next page, please. This is mainly for the audience from the overseas outside Japan, because all the Japanese participants are quite familiar with this 2020 carbon neutrality target announced by the Japanese government. Obviously, this was very interesting because it actually have a clear expression of hydrogen and ammonia, as you can see on the right hand of this page. Next page, please. As explained by Mr. Toyoda in the previous presentation, Japanese government now has already come up with an idea for the governmental support for implementation of hydrogen and ammonia in mainly three different parts of the supply chain. One is the subsidy for the hubs or terminals, as you can see on the middle of this page. And second part is the contract for difference type of the cost supplement. And third is the auction for the power generation capacity, as described as the third item. Next page, please. Finally, I would like to briefly introduce the actual financing cases we started to experience in the past 2 years around hydrogen. Now, first one is already 2.5 years ago, but it's a project financing in Guyana in South America. And because this country traditionally had a very specific energy supply situation, generating a power, generating a power through the diesel power generators, which have a very heavy environmental burden. So this project is financing a project really utilizing a solar power electricity, as well as hydrogen as a storage of the energy. One big factor for the formation of the project financing is the off-taker of EDF, the French power company. That enabled the financing to be formed nicely. And the SMBC really could participate into this deal. Another example, as you can see on the next page, is the very famous one, the project called the Project Helios. Next page, please. The big green ammonia projects in Saudi Arabia. And that was closed in, I think, April last year. This is a very big deal and joined by more than 20 global financial institutions, and also Japanese major banks all participated. And one big factor enabler for this project, or the financing project, was the offtake proposed by Air Products, the American energy company, who have an experienced knowledge about handling an ammonia globally. So, though as we discussed today, we still have a big challenge for the final off-takers of hydrogen and ammonia. We already gradually started to see financing cases to be completed, like these examples. I would pause here and thank you very much for the attention.
Thank you, Kanako-san, for your kind sharing of how SMBC Group has been working towards the social implementation of hydrogen, as well as its transition finance flip book. And during your presentation, we received some interesting questions from our audience, and we are looking forward to have your answer. So first of all, could you please help us explain how do you see the return on your decarbonization investment when you combine the government support measures with the private sector initiatives?
Thank you. Thank you very much for the question. The return, though, if government is really providing support, we private sector as who join the projects cannot take an extra profits. That's of course. On the other hand, there is going to be a reasonable level of returns attached to either equity or debt of those energy infrastructure. So I would say that in the long run, the returns for those new energy infra, both for equity and debt, needs to really boiling down to the level of returns, which is really equivalent for the existing energy infrastructure without excluding environmental value. So new energy infra will get should get an additional returns for the environmental value on the top of the returns for the existing energy infrastructure. That's my understanding. Thank you.
Thank you, Kanako-san, and thanks again for your generous answer. I agree that the private financial sector is actually playing a super significant role of supporting the promotion of GX investment through the expansion of sustainable finance initiatives. And thanks again for your participation as our guest speaker today. After learning Japan's hydrogen policy updates and overall investment situations, let's zoom in and have a further look at the world's first integrated hydrogen validation facility. And now let's welcome Takashi Kishi-san, Executive Vice President at Mitsubishi Power Asia Pacific. And he will make a deep dive into the featured Takasago Hydrogen Park and the prospect of the hydrogen co-firing in Japan. Welcome.
Hello, can you hear me?
Yeah, I can hear you good.
Okay, thank you for your introduction. For me, I'm Takashi Kishine, EVP of the Engineering Department, Mitsubishi Power System, Mitsubishi Power Asia Pacific. So today, I would like to introduce our hydrogen technology for zero carbon emission technology. So let me share the screen. Okay, let me start to make my presentation for decarbonizing energy and society with Mitsubishi Power's hydrogen technology. This is our Mitsubishi Heavy Industries net emission zero target. Our target achieve carbon neutrality by 2040. Generally speaking, 2050 is a target to the zero carbon emission. However, we Mitsubishi is a technology provider. So we can achieve net zero emission by 2040 by applying some advanced technology. This is net zero emission technology target roadmap. We have three key technology. My first one is by applying high efficiency natural gas fired gas turbine, like a JAC gas turbine model, which is our advanced product. This chart shows the horizontal axis, so year, and vertical axis shows CO2 emission reduction level compared with the coal-fired steam power plant. By applying first gas turbine technology, we can reduce the carbon dioxide 65% levels. And another technology for number two is coal-fired ammonia biomass boiler, and also the carbon capture technology, CCU and like CCUS. By applying those technology, we can reduce the CO2 emission by 90%. And finally, zero CO2 emission technology. We are developing hydrogen gas turbine technology and ammonia gas turbine technology, and also the hydrogen production technology. So today, I would like to explain and highlight it to the hydrogen gas turbine development and hydrogen production equipment. This shows our latest product, J-series gas turbine technology features. J-series gas turbine has the three key technology and features. And one is high efficiency level, achieved over the 64% combined cycle efficiency by applying various advanced technology, such as high pressure compressor and enhanced air-cooled combustor, and also the advanced thermal barrier coating for the surface of the cooling blade and burn. Next is a high reliability, achieved beyond the 99.6% of reliability during the over 2 million operation hours in commercial units. And now total 65 units in commercial operation of J and JC gas turbine, and total orders number is 122 units. And also the JC gas turbine has fuel flexibility technology. Of course, the gas turbine can burn the natural gas and distilled oil, and also the by changing to the only combustor portion, this gas turbine can burn the hydrogen and ammonia fuel. That is JC gas turbines' three technology features. This slide shows our combustor technology for the hydrogen firing. We have three technology of the combustion for hydrogen. First one, type 1 is old conventional technology with diffusion firing with water and steam injection to reduce the NOx level. And this technology is already completed to burn the 100% pure hydrogen. The next type 2 is the current technology for the natural gas firing in the gas turbine. We call the premix type dry NOx combustor nozzle. By applying this technology, we can burn the 30% co-firing of hydrogen without modification. So this technology has been completed. And also next target is 50% hydrogen co-firing by applying this same type nozzle. Now we are going to carry actual machine test in autumn of this year. And finally, type 3 combustor we call multi-cluster type combustor. This combustor can burn the 100% pure hydrogen with dry condition. This technology is now under developing. Our target is to complete to this technology by 2025, next year. Those combustor technology we can verify and validate by using the Takasago hydrogen park, as you can see. This hydrogen park is located in our mother factory of Takasago, located in the western side of Japan, close to the Osaka Kobe area. This facility has three types of the facility. First one is a hydrogen production facility, and next is a hydrogen storage facility. And also the utilization through the power generation, we have the two gas turbine in this Takasago hydrogen park. One is the large size gas turbine using JAC gas turbine. The another one is a small type gas turbine, H25, 40 megawatt plus gas turbine. This slide shows the detail of the hydrogen park. This shows hydrogen production. We already installed the alkaline electrolyzer in this inside of the building. This hydrogen electrolyzer has been started to commercial operation from last year. And also we are planning to install another type of the hydrogen production. For example, solid oxide electrolysis cells, SOEC. This type hydrogen production will be installed in this year. And also another type, the methane pyrolysis for the turquoise hydrogen. So this facility will be installed in the 2026 as expected. And also we will install the anion exchange membrane type AEM water electrolyzer. That is hydrogen production. The next facility is hydrogen storage. We installed the total 350 cylinders to storage the hydrogen. And finally, we have two types of gas turbine. One is a large size gas turbine JC and small size gas turbine H25. So we can verify the 30% and 50% hydrogen co-firing test in large size JC gas turbine. And also we can burn the pure hydrogen firing test by utilizing in the H25. This slide shows our first 30% hydrogen co-firing test in last November. That is world first actual machine test by using the large size gas turbine. We can successfully complete the 30% hydrogen co-firing test in the 501 JAC machine for 60 Hz application. So through this actual machine test, we could confirm that not only the gas turbine performance, but also the emission and reliability and so on as expected. So From now, we are planning to two type of the test in this year in the Takasago Hydrogen Park. One is utilizing the JC large frame gas turbine. We will conduct to the 50% hydrogen co-firing test in this autumn. And also other test for middle size, small size 825 gas turbine. We will try to test pure hydrogen firing by applying the type 3 multi-cluster type combustor in this springtime. And also, other than the Takasago Hydrogen Park, we have the many hydrogen project utilizing our gas turbine all over the world. Singapore project and Australian and European and US, we have several projects. Especially, we would like to introduce the Advanced Clean Energy Storage Project. We call the ACES project in USA, Utah States. This project is a very unique project. By applying the excess renewable energy from the solar panel and the wind power, by using this power, we will generate the hydrogen by utilizing the water electrolyzer. A total 15 units of the electrolyzer has been installed in the site. This electrolyzer is the same type of the installed in the Takasago Hydrogen Park. The generated hydrogen to storage using the salt cavern underground. Then this storage hydrogen can be utilized in the power generation with JC gas turbine. Now this project is ongoing. 30% co-firing of hydrogen will be started commercial operation in next year. And further, no later than 2045, pure hydrogen firing will be conducted. And that is ACES project in USA. And finally, this is a summary of our Mitsubishi gas turbine hydrogen roadmap. For large size gas turbine, in order to achieve the EU taxonomy's CO2 emission 270 grams per kilowatt hour, we will try to increase the 50% hydrogen co-firing in this autumn. And for the small size gas turbine, we will try to the pure hydrogen testing using actual machine located in Takasago Machinery Works in this spring. And also the other zero CO2 emission technology, we will developing the ammonia firing gas turbine technology. This gas turbine has this ammonia firing developing will be completed by 2025. And that is our roadmap to zero CO2 emission by applying the hydrogen and ammonia firing gas turbine. Finally, our message is that hydrogen is not the future, it is real today. But that is my presentation. Thank you for your kind attention.
Thank you, Kishini-san, for your kind sharing of the featured Takasago Hydrogen Park, as well as the decarbonization plan for Mitsubishi. And I'm sure it will bring so much reference for the hydrogen co-firing sector, not only in Japan, but also all over the world. And during your presentation, we received some questions from our audience, and we're looking forward to your answers. So first of all, could you please help us explain what are some of the foreseeable challenges for the gas turbine as development process towards 100% pure hydrogen firing?
Yes, thank you for your question. Pure hydrogen fires, as I explained, the type 3 multi-cluster type combustor to prevent the flashback phenomena in firing the burning hydrogen. Now, our rig test of the type 3 combustor has been completed last year. So now we are preparing to conduct the actual machine test in H25 located in Takasago Machinery Works Takasago Hydrogen Park. That is current situation of the to burn the pure hydrogen technology of the gas turbine.
Kishida-san, thanks again for your generous answer. And we also believe that Mitsubishi Power's ambitious aim of improving product reliability through the validation of hydrogen co-firing and 100% hydrogen firing using gas turbine will be achieved in the near future. Thanks again for your participation.
Yeah, thank you very much.
And now, without further ado, let me introduce the last keynote speech of today's webinar. Mr. Hidetaka Endo, the GX advisor from Mitsubishi Kakoki, will present a keynote speech on leveraging Japan's industrial competitiveness in global hydrogen through the commercialization of Japan-developed hydrogen technology. So Endo-san, please start your presentation.
Okay, thank you very much for my introduction. And I would like to start my explanation. So may I share my my presentation? Okay, could you give us the control rights?
Yes, please share your screen.
Okay. Hello. Yes, this time is my presentation. The theme is leveraging Japan's industrial competitiveness in the hydrogen through the commercialization or commercialization. And sorry, I can't see that. Okay. Let's go. So my company is a Mitsubishi Kakoki Kaisha. It's a kind of the chemical engineering companies. So in the context of hydrogen industry, we are much player. So why I so? So please see this slide. This is METI's concept to develop the hydrogen society in Japan. Public sector and private sector concentrate on the supply chain, establishing supply chain and developing the demand simultaneously. So this is the overseas. Yes, overseas area we produce the green or blue hydrogen at a lower cost than the Japan. So we transport it and supply to the each users. Large-scale power plants, steel making, chemical process, mobility, fuel cell or heat, and so on. But not only the international supply chain, Japan have engaged in the domestic production and supply to these clients or these customers. But so each section produce, transport, and use. Each company have advantage in each section. But Mitsubishi Kakoki it's a kind of the multiplayer. So Mitsubishi Coffee can supply the electrolyzer to who wants to produce green hydrogen, and we have a we have a history to supply the hydrogen service to the facility owners, especially in the chemical plants or some manufacturer factories and so on. So each players we can support each players use hydrogen infrastructures. And but these days, this supply chain and demand process, to my regret, they have the GHG production at the same time. So we need to solve these problems. So, for example, our chemical plant, our engineering players may collaborate with some emission trading companies. So, such a combination will be the effective solution in the Japanese society. For example, GHG production, these players, but mobility players, if they induce the FC vehicle or FC truck, FC bus, they can get the emission trading rights. Okay, a fixed fuel cell and heat, hydrogen boiler, and so on are the same thing. So, for example, Bywell is the biggest company to reach the J credit. So such a company supports their emission rights to money. So such a emission rights change to the J credit. It's kind of the compliance emission credit. So those players get such a offset solution. So totally in Japan, we realize a carbon neutral 2050. And let's return to the hydrogen business. So, as you know, Japan in 2020, October, declared carbon neutrality 2050, and next year revised the green growth strategy. And last year, 2023, a hydrogen basic strategy was revised. And this year, in the Japanese diet, today discuss the Hydrogen Society Promotion Bill, and this bill will be law until the June. So, Japanese society, Japanese market will have a good support from the public sectors, for example, subsidiary or CFD. It's a compensation for price difference in green hydrogen ammonia compared to the fossil fuel. And such a CFD will be started within the 2024, fiscal year 2024. So this circumstance is a very good tailwind for the Japanese hydrogen businesses. And how about the industry players? Since 2040, Toyota and Honda started the XCV business. It's a mobility have been leading the Japanese hydrogen businesses. And since 2015, green hydrogen energy system was released by Toshiba. I was a member to establish this business. So but now, sorry, but now 2023, we Japanese market will need more hydrogen because sorry, because that excuse me, hydrogen's high consumption will be commercialized after 2025. So, for example, JERA, co-firing thermal power plants, hydrogen 30% co-firing in 2030s, and ammonia NH3 20% in 2020s, and 50% in 2030s, and 100% in 2040s, according to the JERA's press release. And Tokyo Gas and Osaka Gas facilitates the methanation. Methanation is a green or blue hydrogen and CO2. It's a good solution for the Japanese industry players. And in 2025, Kansai Osaka Expo, Iwatani and Namura Zosen, Namura Shipbuilding, will realize that hydrogen fuel cell ship, 130% plus, and they will commercialize it swiftly. And Toyota, Honda, Isuzu now engage in the FC truck. That FC truck will be commercialized in the latter half of the 2020s. And so next explain each item which will consume the huge amount of hydrogen. So the top one is the summer power plants. Japan will shift now, as you know, Japan make efforts to increase the renewable energy, but at the same time, Mitsubishi Heavy Industry and other main players accelerate to realize the hydrogen co-firing and ammonia co-firing summer power plants. For example, Mitsubishi Heavy Industry will realize a 30% firing summer power plant system at around the 2025, and perhaps 100% summer power plant system in 2030. But it's a manufacturer's view. So JERA, it's a user's view. JERA will commercialize hydrogen firing 30% in the 2030s, and ammonia firing 20% in the 2020s. And KEPCO will commercialize hydrogen co-firing summer plants in 2030s. So such a big players will use these manufacturers' items. So for users and suppliers, demand and supply balance is very good. So Japanese hydrogen market is very promising. And in addition to that, do you know Jenbacher? It's a kind of Australian makers of the power plants. So in Japan, Hitachi treated. So such a Jenbacher's summer power plants can aid co-firing or 100% hydrogen summer power plants can be realized since the 2021 summer. So technically, Japanese summer power plants is a carbon neutral summer power plants can be realized, and we wait the users preparation to start their business the business. And next one is big consumption. Now, I expect big consumption is a SIP. Okay. So Japanese public sector, METI or MRIT, and is supposed to realize a fuel cell hydrogen powered ship or an ammonia powered ship. And such efforts have made a fruit. Oh boy. Oh, I'm sorry. Okay. So please see that. As I said, in 2025, next year, Japan held the Osaka Kansai Expo. At the time, Iwatani and Namura shipbuilding realized the FC ship, 100% FC ship. But strictly speaking, it is a hydrogen fuel cell and lithium batteries powered ship, but carbon neutral ship. After this expo, it will Hankyū railway companies will operate this cruising service, cruising service commercial. Oh, sorry. And next one, do you know this picture? This is the ship name is Hydro Bingo. The ship is Hydro Bingo. Now, it is operated in the Setonai. It's a middle zone. It's a famous important industrial area in Japan. But this area originally used ferry or water bus to commute in their daily life. So Tsunei shipping is a shipping builders and Belgian companies collaborate to make this hydrogen and diesel co-firing ship. Strictly speaking, it is not carbon neutral, but almost carbon neutral ship. But now, as you know, Japan hydrogen fuel is very expensive now. They use biofuel. But as I said, in fiscal year 2020, within fiscal year 2024, Japan will start the CFD, so they can use the hydrogen as a fuel. At the time, this ship will be operated by the hydrogen fuel. So this kind, so not only the FCV, but also the ship infrastructure will be changed to the hydrogen. So perhaps and Iwatani will start the hydrogen supply station for ship in 2024. But in Japan, ship hydrogen in the ship industry will be realized, will be accelerated. And Mitsubishi Kakoki is a good player to engineering the hydrogen station, so we can make the hydrogen supply station not only for the FCV but also the ship. It will be the good business chance for us. And the next one is airplane. Yes, Kawasaki Heavy Industry engaging in developing the liquid hydrogen engine and liquid hydrogen tank for the aircraft. It is a good point. Our team wants to explore our new business in the aircraft field. And next one is FC truck. Generally speaking, FC truck and FC bus will consume the 45 times of the FCV. So it will be the big consumer of the hydrogen. So around the 20, so many companies, not only the truck company, but also the transportation company, enthusiastically develop the business know-how or know-how as in the practical test now. But it will be commercialized soon. And Honda will be commercialized this big size truck. It can run 800 kilometers. It will be commercialized in 2027. And Toyota and Isuzu will launch a small scale fuel cell truck. Perhaps 2 tons or so. It will be used for the convenience stores, delivery and so on. But it is operators' needs are very strong to the size of the truck. So Toyota and Isuzu will be commercialized at around half of the 2020s. And so the Japanese FC trucks market will be promising too. Yes. Increasing the FC truck and such a kind of mobility use of the hydrogen. So Japanese government have a plan to want to increase the hydrogen station. Now only 161, but it will be increased to the 1,000, about 1,000 until the 2030. I believe the Japanese society will realize this will realize this plan. And in addition to that, so big consumer is a methanation. So Tokyo Gas and Osaka Gas, such a number one gas retailer, Tokyo Gas, and a second gas retailer, Osaka Gas, have been engaging in realizing the this technology, and they declared they would supply the 1% of their sales amount as methanations synthesized gas. But so this solution needs chemical engineering like us. So Mitsubishi Kakoki may get a business chance in this good market. And not only the methanation, but also e-fuel for mobility and SAF now will be realized in near future. So JFE and Itochu, such a kind of the major companies are struggling to realize, conducting the practical test, conducting the feasibility study, and will start the practical test, not only in Japan, but also the international supply chains. So I expect that e-fuel will be commercialized in the near future in the Japanese market. And last one is steel. The steel maker is a good client for Mitsubishi Kakoki. And their plant needs carbon reduction. So governmental agencies release hydrogen reduction steel making technology. That project name is COS 50. And Nippon Steel or JFE joins the project and leads the carbon neutral steel making process. So, for example, Nippon Steel will challenge a 50% decrease in CO2 emissions in the steelmaking process. It's a very ambitious, but I believe they can realize it. And to support, METI decided financial support will increase original plan. Original plan is 1.3 billion US dollar, but it will increase. It will increase. Sorry, it increased $3 billion, about $3 billion, and the plan, basic plan is 2045 complete, but ahead of the schedule. METI declared that plan will be completed in 2040. So such a declaration is September in 2023. So Japanese market needs more hydrogen supply chain and demand side. So Mitsubishi Kakoki wants to contribute those needs as a chemical engineering multiplayer. That's all. Thank you very much.
Endo-san, I very much appreciate your impressive and comprehensive presentation on the key consideration for sharing of Japan's industrial competitiveness in global hydrogen and consideration for the commercialization of Japan developed hydrogen technology in different scenarios in your presentation. And during your presentation, we received so many questions from our online audience, and I would like to select one questions due to the time restriction. So could you please, with regards to the hydrogen application in mobility sector, could you please help us explain that what makes Mitsubishi confident about the Japanese market will be more viable in the short to medium term in terms of the refilling station, because there are so many companies are closing down their hydrogen refilling station across the world?
It's a good question. Yes. About the FCV, it's like a Toyota Mirai or Honda Clarity, and such a small size FCV don't consume the hydrogen too much. So many hydrogen stations players suffer from the small needs and difficult to commercialize it. Yes, exactly. Exactly, that is a problem. But as I mentioned, FC truck and FC ship, we will consume more hydrogen. So hydrogen stations, supply stations business player will increase their business chance. So I think, I suppose the governmental plan, the hydrogen station increase the 1,000 until 2030 will be able to realize, I think. So not only FCV, normal FCV, but also the more FC truck, FC bus, and Japan will start the hydrogen supply station for ships in 2024. And in addition to that, Tokyo Governor Ms. Koike clearly declared this Tokyo need to prepare for the hydrogen supply station for the near future. Perhaps not only the Osaka, Kansai area, but also the Tokyo area, Tokyo Bay Area will have the will increase such a new type hydrogen station gradually. But until 2030, perhaps we will see the many hydrogen stations and enough number of the hydrogen stations as FC mobility or mobility fields infrastructures. Sorry, answer too long.
Thank you, Endo-san, for your very informative sharing and generous answer to the question. And thanks again for your contribution to our webinar today.
Yeah, thank you.
And now it comes to an end of today's Impact webinar. Today, we've delved deeply into the ambitious yet crucial target outlined in Japan's revised hydrogen basic strategy. We've explored the immense potential for innovation, collaborations, and investment that this vision presents, along with the challenges that lie ahead of the path to achieving a sustainable hydrogen society. From insightful perspectives shared by our distinguished speakers, it is clear while there are hurdles to overcome, there is also an abundance of opportunities waiting to be seized. Whether it's enhancing technology competitiveness, optimizing the global supply chains, or fostering international cooperation, each step forward brings us closer to realizing the transformative impact of hydrogen on our energy landscape. Once again, please remember, today's Impact webinar is also a virtual session of Asia's top 1 comprehensive hydrogen event, Connecting Green Hydrogen Japan 2022-4, which will take place from October 16 to 17th at Balaso Shibuya Garden, Tokyo. In addition to your participation in today's webinar, we also look forward to meeting you in person at this flagship hydrogen events to discuss the latest innovations and fill your business future by meaningful connection. Our journey doesn't end here, it's just the beginning. To identify next step, mitigating risk, expanding global engagement, and shaping future of hydrogen on a global scale are not only aspirations, but also actionable goals. They demand concerted efforts and collaborations among governments, industries, and innovators. We hope you found this discussion of today insightful and informative. And thank you for your participation of today's webinar. See you next time.